Alright, so today what we're going to do is we're going to finish up double angle identities, and then for homework I'll give you a worksheet, and actually tomorrow all we're going to do is just work on another worksheet too. Alright, so today there are 5 examples I wanted to go over with you. So let's get started. Today is the first, and let's take a look. We're going to be on section 5.5, and it's called double angle identities. And this is actually day 3. Alright, so for our first problem, it looks like this. We're going to be solving the sine squared of x plus the cosine of 2x minus the cosine of x. Now, whenever we try to solve formulas, we always want to try to get the same trig function. So I'm looking here, and I know cosine of 2x, there's 3 different ways I can go. But it might be a good idea if we just convert everything to cosines. So if sine squared plus cosine squared is 1, then sine squared would be 1 minus the cosine squared of x. And the cosine of 2x, looking at my formula sheet, is going to be 2 cosine squared of x minus 1. And then we have minus cosine of x equals 0. So we do have all cosines. This one and this one would cancel. And we would get the cosine squared of x minus cosine of x is equal to 0. If we factor out a cosine, when is cosine 0? Well, cosine 0 right here and right here. That would be at 90 degrees and at 270, which using x, 90 degrees is pi over 2 radians, and 270 would be 3 pi over 2. All the problems that we're doing today is we're going to be looking for answers between 0 degrees and, between 0 radians and 2 pi. So we don't have to add the period at the end. And then when is the cosine of x minus 1 equal to 0, or when is cosine of x equal to 1? Well, it's a quadrantal angle, and that would happen at 0 degrees or at 0 radians. Okay, 4 more to go. Number 2. It says the sine of 2x sine of x plus cosine of 2x cosine of x is equal to 1. Now we have a lot of different options here, and you could solve this a lot of different ways. For me looking at this, I know automatically this has to use the formula 2 sine of x cosine of x. Now the cosine of 2x, that could go a few different ways. I already see it's paired with a cosine, so I'm going to look to use the cosine formula. You could use other ones. There's really no right way to do this. We just have a lot of different options. That's part of being in an honors class. We should be able to get the same answer using different options. So I'm just going to use the formula for cosine of 2x. I'm going to use 2 cosine squared of x minus 1. I'm going to multiply that by cosine of x. And then we should be able to get the answer doing it this way. Let's see what happens. Sine x times sine x is sine squared of x, which I'm just thinking that's a Pythagorean identity, but I'll keep that in my back pocket. And then this would be plus 2 cosine cubed of x minus cosine of x, and that's equal to 1. All right, so it looks like we have a lot of cosines except this. So if sine squared plus cosine squared is 1, that would mean sine squared is cosine squared. Let me see here. If we rearrange this, bring the cosine over, sine squared would be 1 minus cosine squared of x times cosine of x. All right, so we have a big mess. let's start simplifying, try to distribute everything out, and then let's see what we have. All right, so I don't know about you, but I'm pretty relieved that these are going to cancel. I was getting a little worried about how we would handle that, but anyway, let's see here. 2 cosine of x minus cosine of x is just cosine of x is equal to 1. All right, well, that cleared up in a hurry here. 1's cosine 1 right here when x is 0 or 0 radians or 0 degrees. All right, so that's cool. Let's take a look at number 3. Number 3 is similar to homework 1 from yesterday. We have the sine of 4x minus the cosine of 2x. Now, the way that we handled a problem like this yesterday is we used a double angle or a sum and difference formula. So this is really just the sine of 2x plus 2x minus the cosine of 2x equals 0. So the formula says we could write this, I don't know what that is, we could write this as sine of the first, cosine of the second, same sign, cosine of the first, sine of the second. Now I'm looking and I see cosine of 2x, cosine of 2x, and cosine of 2x. So let's factor it out and see what we're left with. All right, well, when is cosine of 2x equal to 0? Well, if we take the inverse cosine of both sides, we get 2x is equal to, what angle gives you a cosine of 0? Cosine of 0 we would get right here at 90 degrees and right here at 270 degrees. So x would be 45 if we divide both sides by 2, and x would be 135. That's not a big deal. Let's see what happens with 2 sine of 2x is equal to 1. Well, if we bring the 2 over and take the inverse sine of both sides, we get 2x is equal to, well, what angle gives us a sine of 1/2? Looks like if it's positive 1/2, we could draw it right here, and the sine of 30 would make that happen, and the sine of 150. So x would be 15 degrees, and x would be 75 degrees. All right, we have 2 more problems to go. All right, so what about the cosine of 2x plus the cosine of 4x is equal to 0? Well, I know the cosine of 4x is going to be the cosine of 2x plus 2x. We saw this in the homework the other day, and we just saw this in the last problem. So using our sum formula, this would be the cosine of 2x times the cosine of 2x, opposite sign, and then the sine of 2x, sine of 2x. Now, what I'm thinking we could do is, this is just going to be, let's see, this is a formula, and this is a formula. And it looks like this part is going to just turn into negative 4 sine squared of x cosine squared of x. Now on the left side, we have a lot of different options we could do. Again, we have 3 different formulas for this. So I think what I'm going to do is I could always convert this part into a cosine. So I'm going to try to write everything in terms of cosines. So the first cosine of 2x using cosines would be 2 cosine squared of x minus 1. And this is going to be 2 cosine squared of x minus 1 times 2 cosine squared of x minus 1. And I'm going to try to get everything in terms of cosine. Let's see what happens. And instead of writing sine squared, I'd prefer just to have everything in terms of cosine. That just makes me feel better. So I'm going to convert that. Sine squared is equal to 1 minus the cosine squared of x. All right, so let's see what we're working with here. 2 cosine squared of x minus 2 cosine squared of x cancels. Negative 1 plus 1. So this would give us 4 cosine squared of x minus 2 cosine squared of x minus 4 times cosine squared of x minus cosine to the 4th of x. This would be 2 cosine squared of x minus 4 cosine squared of x minus 4 cosine to the 4th of x equals 0. All right. So I can combine these. Negative 2 cosine squared of x minus 4 cosine to the 4th of x equals 0. We could divide out by negative 2 cosine squared of x, and we're left with 1 minus 2 cosine squared of x is equal to 0. Ay, ay, ay. All right, so let's see what happens here. When is negative 2 cosine squared of x equal to 0? Or when is cosine squared of x equal to 0 if we divide both sides by negative 2? If we take the square root, we get plus or minus 0. When is cosine of x 0? The x value, right here at 90 and right here at 270. So 90 degrees and 270. All right. So there's a light at the end of the tunnel. We're almost there. And then what about this one? So 1 minus 2 cosine squared of x is equal to 0. Bring the 1 and divide by 2. Go take the square root. We get that the cosine of x is equal to positive 1 over root 2. And the cosine of x would equal negative 1 over root 2. Well, cosine of x would be 1 over root 2 in this quadrant and in this quadrant. So x would be 45 degrees, and x would be 315. We'll convert those to radians in a minute. It would be negative right here and negative right here. And that's at 135 and at 225. So let me convert those quickly for us. 45 degrees is pi over 4. 315. 7 pi over 4. 135 is 3 pi over 4. And then 225 is 5 pi over 4. All right, and we have one more to go. Let's do number 5. For number 5, it says sine of x plus the sine of 3x is equal to 0. Well, just like before, we used a sum and difference formula and a double angle. So sometimes we have to use multiple formulas. Sometimes we might even have to use the Pythagorean formula. So let's see what happens. Sine of x plus, this is the sine of x plus 2x is equal to 0. So the sine of x plus sine of the first, cosine of the second, same sign, cosine of the first, sine of the second. I'm going to try to use all, it doesn't matter what we use, but I'm going to convert this to a sine so that we would get a sine squared here. I'm going to try to convert this to cosine, so this might turn into a cosine squared. We could use multiple different ways, that's just what I'm thinking. So looking at my formula sheet, we would get the sine of x plus sine of x, and cosine of 2x in terms of sine would be 1 minus 2 sine squared of x, plus the cosine of x times sine of 2x would be 2 cosine squared of x minus 1 is equal to 0. All right, let's try to simplify and see if there's anything we could do. So we get the sine of x plus sine of x minus 2 sine cubed of x plus 2 cosine cubed of x minus the cosine of x is equal to 0. All right. So what could we do here? Well, this would definitely be 2 sine of x minus cosine of x. Then we have minus 2 sine cubed of x plus 2 cosine cubed of x is equal to 0. All right. Well, trying to figure out what we could do with this. Is there a way we could try to get all the same trig functions? I think I made a mistake over here. Right there.